Hi everyone, welcome back to Global AI Community on Virtual Tour. We have had so many sessions already today, but now myself and Iliescu as hosts are joined by Vlad. Vlad is, I love the bio you provided, by day works at Strong Bytes as head of AI, but by night organises NDR, which is an annual AI conference that's held in two of Romania's largest cities. And it's also, I don't know how you have the time, it's also a Microsoft Most Valuable Professional based around AI. So hi Vlad, thank you so much for joining us.
Well, hi Amy and hi Iliescu. Happy to be here. My secret is that I don't sleep at all.
You don't sleep at all. I was going to say, and so are you in Romania right now?
Yes, I'm in Romania. It's about 2 p.m.
2
here.
p.m. Okay. It's lunchtime here, so it's sort of midday here in the UK. But I won't be thinking about my stomach on this one because I'm really excited to hear your session. So getting ahead in Kaggle competitions with automated machine learning, two very exciting subjects. So I guess without further ado, please just jump into the content. We're all excited to see it.
I will. Thank you, Amy. Well, as I said, I'm going to look at the bigger screen now. This talk is about getting ahead in Kaggle competitions with automated machine learning. But that's more of a, well, what should I say? A bit of a trap. I just put that here to attract everyone. It's actually about getting ahead in Kaggle competitions with as little effort as possible, actually. So I'm going to try and do that, and yeah, see how far I can go. Not sure if all the viewers are familiar with Kaggle. It's well, I'm gonna click. It's a really cool well, community of data scientists and machine learning practitioners that, amongst other things, hosts a lot of well, machine learning competitions. And the Titanic ML competition is one of their getting started competitions. Yeah, it basically it tasks you to predict which of the Titanic passengers will live and which of them will live less. Yeah, they give you a couple of data sets, you know, with several pieces of information regarding the passengers, such as whether or not they survived. That's our label. That's what we're trying to predict. But also the passenger class, their name, their gender, the age, how old were they, yeah, how many people they traveled with, their ticket number, and so on and so forth. But as I said, we're trying to do this with as little effort as possible, so we're not going to trouble ourselves too much by trying to understand this yet, right? It's important to know that they give us 3 data sets, yeah, as CSV files. One is the training data set, which we should use to train our machine learning models. The other one is the testing data set, which is exactly the same as the training data set, except for the survived column. Yeah, that's the label. That's what we're trying to predict. So they don't have that. So basically, what we need to do is train a model off of trained CSV, run it on test CSV, submit this data to the Kaggle website. They'll evaluate our model performance, see how good it is, and yeah, who knows? Maybe we'll get a top score. Let's see how we do that, right? So for this, I've got this fancy Jupyter notebook that reiterates who I am, but I won't go through this again. And first things first, well, I've already downloaded the training and testing data set. Let's take a look at them, see how they look like. Yeah. The training data set, as we've seen on the website, it has a few columns, something like 12 columns, a passenger ID, whether or not they survived, the class, the name, the sex, siblings, parents and children, and so on. Yeah, testing data set, absolutely the same, except for the survived column, which is not present. Yeah, and well, they also give us a sample submission, how this should look like. So basically, the sample submission just includes, it's a CSV with 2 columns. It includes the passenger ID, yeah, so we can uniquely identify the passenger, and whether or not they survived. Yeah, and that's what we're trying to submit. So let's try to solve this using scikit-learn, you know, Python's de facto machine learning library. And yeah, I'll just try to do this as easy as possible. So I'm going to import the decision tree because I've heard decision trees are really good. So I'm going to import this class. I'm going to split my training data set into two different data sets. Yeah. One is X. So basically, these are the features. This is the data that we will use to be able to predict a label, whether or not a passenger survived. And in Y, I'm storing the value of the survived column. Yeah, so this is actually the thing we're trying to predict. And I'm going to run this. It works. I'm going to instantiate a new model with a decision tree classifier. And by the way, this is a classification problem. Yes, it's not a regression or anything. Yeah, we just need to survive. Well, stay alive to predict whether or not somebody lived or died. Yeah, put them into one of the two available buckets. So it's a classification problem. We're not trying to predict a continuous value, which would make it a regression problem. All right. So again, using the classifier, I'm gonna try and fit it. Yeah, to see if it can try to predict. And I don't think it's going so well. It appears to be throwing an error. And if we look at the reason, it says here that it could not convert Mr. Owen Harris to a float. Why does it say this? Well, it says this because, well, machine learning works with numbers. Yeah, the algorithms work with numbers at their core. And this is a string. So we should process it somehow and make it a number. I can already feel the cogs turning a little, so I must do something to stop them. So if we take a look at the structure of the data set, we can see that some of the features are integers, so integers. They could be used to train the ML models. Yeah, some of them are float, like age, but the name is an object, it's a string. The sex is an object. Tickets are objects of strings. We cannot use them without doing some sort of a processing. But we said we'd do this. I said we'd do this as simple, as easy as possible. So I'm just gonna throw the features that I cannot process right away. I'm gonna throw them away. Yeah, not use them. So discard them. Just use the passenger ID, passenger class, age, siblings, spouses, parents, and children, and fare. No string features. Store them again in the X dataset and try to do a fit. It must work this time, only it doesn't. Some other issue here. Input contains none or infinity, or even a value too large. Well, let's do the info dance again and see what's in the dataset. Something must be wrong. And we can see here that out of 891 rows, the age is missing for something like 200 rows. So we must do something about that. Yeah, machine learning in this case, it cannot handle null value, non-existing value. So we need to decide. One option is to just drop the age, but it seems like the age would be correlated with survival. So we shouldn't do that. Yeah. Another option is to just drop the rows with null age values. But again, this is a really small data set, so only about 900 values. If we drop 200 rows out of them, it won't have a lot of predictive power. Yeah. So let's see if we can do something about that. And well, I'm gonna do something about that. And I'm gonna calculate the mean, not even the median, the mean of all the age values, and just put it there. Yeah, assume that the people who didn't have an active age, filled in age, they're all 27. Let's be generous, and try to do the fit once again. Oh, and oh my God, I cannot believe this. It works. Best thing that happened today. Yeah, it works. We have a trained decision tree classifier. Now let's just use it on the testing data set and see how that works. Maybe even submit some results to Kaggle. Yeah. I'm going to do a model predict. So first, I'm going to select the data set. I'm going to use the columns that I used to train the model and select a subset of the testing data set. Yeah. Try to run a predict, and it crashes. This is beautiful. So it crashes. Why? Because input once again contains none, infinity, or value too large. My bad. the moral of the story here is that all the pre-processing that has been done on the training data set needs to also be done on the testing data set. Yeah. So I should also do a fill NA on the testing data set, and surely this time works. It doesn't work this time because it's a lovely data set. Input once again contains none, infinity, or value too large. How is that? Let's check, right? And we can see that for one measly person who didn't have their fare, just in the testing data set, it crashes. So I'm going to do another fill NA here on the fare this time. And this is the beautifulest matrix I've ever seen today. It works. We're here. It works, but it didn't work without, well, let's say a lot of blood, sweat, and tears on my side. Yeah, I had to think. Yeah, I had to look at the data a bit. I had to, well, discard what I couldn't process, process what I couldn't discard, and so on and so on, just to train a model. And let's see how well I did. Yeah. So I'm gonna store the I'm gonna run the predict again and store the results of the prediction in an array, and then just fill in a new data frame out of this. So it looks good, I think. I'm gonna then, if it looks so good, let's just write this as CSV and upload it to Kaggle. I'm gonna do a submit prediction. Okay, it's initializing the upload, uploading. It's uploaded. Let's make a submission. Not a lot of people are active on Kaggle at the moment, and that's nice. And it's initializing. I had to say, I tried this a couple of nights ago, and there were so many people in the queue that I don't know, the whole thing took like 5 minutes. So if this takes a while, I'm just gonna switch to the notebook, and we'll check our score once again. I'm gonna do a quick refresh.
Quick question for you, Vlad.
Yes.
Do you, like when you were building this originally, did you submit sort of as many submissions as you want to Kaggle, or is there like a certain amount that you're allowed to do?
Yeah, it's a good question. You are allowed to do at most 10 submissions per day.
Oh, okay. So it's quite a lot, I guess.
It's quite a lot. What somebody with well, what you might want to do first is when you train a model to also test that model. I kind of skipped that. Yeah, but ideally you would want to split the training data set into 2, maybe 3 other smaller data sets that you can use to evaluate your model. And that's actually a good question, even though I did not do that. Later on, we'll see how automated ML does that for us.
Okay, great stuff. Thank you.
I have grabbed the coffee. Unfortunately, so I cannot grab one now. If this doesn't, 2 minutes ago. Okay. Let's assume we've seen the results, and we'll see them soon. I had to add in an XKCD strip here, but yeah, basically, if we have a problem, yeah, all developers will try to fix it with algorithms. Whether or not they succeed is a different business. But yeah, this is a solution to all the messing around, to all the pre-processing, to all the thinking, that we've done before. It's automated ML. And for this automated ML part, I'm going to use well, Microsoft's automated ML library. I have to say this is so far my favorite AutoML library. There are some others, including some open source libraries that you can use. What I love about this is that it's, on the one hand, it's continually improved, and it's very deeply integrated with the whole Azure ecosystem. I'm not going to go into that deep integration because, well, time is of the essence. But if you want to, you can just go to, well, documentation. I'm going to put all this Jupyter notebook online later on, so you can reproduce my results, and you can go through those tutorials. They're really well written, and try them out yourselves. Yeah, but so in order to have this going, I need an Azure account, even though the automated ML will not run in my Azure account, in my Azure cloud for now. I've chosen to run it on my machine, but I'm gonna need an Azure account, and I'm gonna need a resource group with a machine learning service workspace, which I've already created. Yeah, and I'm gonna need, of course, the Azure ML SDK. As you can see, I think I have the latest version. I've done an update 2 days ago. And well, just a moment. Ooh, still going. The beauty of doing live demos when everybody stays at home and competes in Kaggle competitions. All right, but what I'm going to do next is well, authenticate to Azure. Yeah, for this I'm using the interactive login authentication. I'm gonna associate. I'm going to link my my workspace that I'm going to use for this. Yeah, and I'm going to create a new experiment, aptly named Titanic, because I'm really original. Yeah, and what do we have here? This is the part that I'm going to start running at the moment, because it takes something like 2 minutes to run on my machine. And yeah, let's see what happens here. Basically, this is where I'm configuring automated ML, and this is where I'm running it. Yeah, and how am I configuring this? Yeah, I'm telling it, look, this is a classification task. By default, automated ML Microsoft implementation supports classification, regression, so predicting buckets or numbers, and my favorite part, time series. It has a really nice time series implementation. Yeah, I quite love it. Yeah, but for now, what are we doing? We're doing classification. Yeah, the primary metric, well, this one depends on the problem. Yeah, in the Titanic, basically, in this data set, you have something like, I think 60% of people who didn't survive and 40% of people who survived. So the metrics are kind of balanced. Yeah, accuracy. So you don't need to use, well, metrics such as precision or recall. You can get away with just using accuracy or area under curve. In my case, I went with area under curve. Yeah, I'm letting it run for 3 iterations. We'll get to this in a moment and see what an iteration really is. But basically, the more iterations we have, the more combinations automated ML tries. Yeah, I'm telling it that, look, this is the training data is stored in my in the train data frame. And this is the label that I want you to predict. Yeah, survived. And by the way, I want you to test your predictions. Yeah, not unlike I did earlier on. Yeah, and I want you to do cross-validation. Now, if this was a big room, I would ask you, do you know what cross-validation is? But I'm gonna assume not a lot of people will raise their hands, or I'm not seeing them. Yeah, so what is this cross-validation thing? Well, how do we test machine learning models? One option, the basic option, is to just train them on a data set and test them on the same data set. But that's a bad option, you know, because this basically, you tell the model these are the results, and then you ask it, but what were the results? It's not fair. Yeah, you want to see while testing a model, you want to see how well it adapts to new and unseen data sets. Yeah. New and unseen challenges. You want to see how well it generalizes. Another option, well, this brings us to option 2, is to split the data set into 2 other data sets. Yeah, one that you use for training and the other that you use for evaluating the model trained on the training data set. And that's good, that's fine and dandy, unless you realize that you might have some hidden bias in either the data set that you use for training the model or in the data set that you used for testing the model. So that might get you some steps ahead, but not that much, right? So then you might think about slicing the data set, yeah, which is what cross-validation is all about. Yeah, you take the whole data set you slice it into, well, in our case, into 5 slices, and use 4 of the slices to train a model, and the remaining slice to evaluate it. Then use 4 other slices to train the model, and another slice to evaluate it, and so on and so on for each of the possible combinations of the 5 slices. So this gives you a better idea of how the model handles unseen data. And basically, this is what automated ML does, yeah. Which is, again, pretty cool. I just had to write 1 line for this, right? Then I'm telling it, look, if an iteration, yeah, if an iteration takes more than a minute, just throw it away. I don't want it. And then what used to happen, and what I had in my notebook before updating to the latest version of the SDK, was in order to handle the pre-processing part for me, yeah, in order to be able to handle strings or missing values or a lot of goodness, we'll get to that in a moment, I had to write this pre-process equals true. Yeah, otherwise this wouldn't have worked. Yeah, it would complain that my data is none or empty or infinity, whatever. Yeah, but now you don't. Now you have to write featureization equals auto or off. And by the way, now it's auto by default. So now it's enabled by default. So I don't have to write anything. Yeah. Just setting for verbosity to info because I want to log everything. And well, model explainability, we'll get to that in a moment, but I don't want it for now. Yeah. And let's see what it did. Well, it evaluated the data set. It gathered some characteristics. It generates some features. Basically, how this works, automated ML is something like a recommendation engine for machine learning algorithms. Yeah, it looks at the structure of your data set. It looks at how many features you have, how those features look like. Are they strings? Are they numeric? How many nodes do they have? And based on these characteristics, it recommends you a machine learning algorithm with some hyperparameters, yeah, because those matter too. Yeah, so you might get, I don't know, at first you might get a linear logistic regression in our case with some hyperparameters. Then after it evaluates this logistic regression and sees that it doesn't do that well, it might recommend something else, and so on and so on. For each and every recommendation can be seen as an iteration, yeah. It looks at the data set, it recommends a pipeline, yeah, a predictive pipeline, evaluates that pipeline, and based on the evaluation results, it recommends another, and so on and so on, until you tell it to stop. Yeah, this is kind of how it works. Okay, and what is here? Yeah, they're detecting whether or not the classes are balanced. Good check. I didn't do this before, right? And yeah, the classes are balanced. It detects whether or not some values need imputation, and it detects that age and imputation, age should be imputed. Cabin and embarked, maybe they also have nulls. This is the one I really like. Whether or not some features have a high cardinality, like, yeah, have a lot of values that change all through the samples, all through the passengers. So those features might not be good predictors. Yeah, and we have a really interesting high cardinality feature that we'll see it doesn't detect, which is the passenger ID that actually changes for each and every one of the passengers. Yeah. What happens next? Yeah, it tests several pipelines. So an automated ML pipeline is formed of by default of 2 steps: a scaler and an algorithm with some hyperparameters. Yeah, the scaler basically ensures that all the values are in the same value space. Yeah, that we don't have, for example, I don't know, millions values whose range who range in the millions, and the values that are something like 0.1, 0.2, and stuff like that. They need to be in the same space for some algorithms to work well with them. So they have combinations of scalars and algorithms. And we can see that the first time it evaluated the combination of max ABS scalar, which is a standard scikit scalar, by the way. So this is an open source class. Yeah, these aren't just I don't know, Microsoft implementations of algorithms. These are open source components that you can use outside this. That you can check, that you can inspect, you can read the source code, you can do all sorts of fun stuff with them. So this is something to take into consideration. So it uses the max ABS scaler. It uses a gradient boosting algorithm, LightGBM, which is from Microsoft, but it could also use, for example, maybe you've heard of XJBoost or CatBoost. It could also use some other implementations. How much it took to evaluate this thing, and how well it did. This is our area under curve. And we can see that the first combination got 0.85 to 4. Our second combination, even if it uses the same algorithm and scalar, but it uses them with different settings, it took less and it got a better performance. And then it also evaluates the SGD, and it could not compete with LightGBM. Okay, we can also look at this, and we'll see a nice visualization of the iteration. It's much more impressive if we have more iterations, but then it would have taken the whole presentation time, and I didn't want to show that. So, but the fun part is that you can also evaluate them based on other metrics. So you might get the best model based on the metrics you entered here. The area under curve. But let's say you wanted to look at how well they did accuracy-wise. In this case, the first implementation actually did better. That has the highest accuracy. The best implementation from the standpoint of the area under curve, it's actually the worst as accuracy. So which metric will you use? It's a decision you need to make. But we're going to look, well, not macro, but weighted. We're going to look at the AUC macro. And then I'm going to use this local run to actually get the model that I've trained. It might take a couple of minutes, but this is how the model looks like. This is the best model. You'll notice it's a pipeline. And this is, well, not sure if you know it, but this is a scikit pipeline. A standard scikit pipeline. Again, open source, nothing too fancy. Which you can also build by hand if you need to. So it's this pipeline, and it has a series of steps. And we'll look at those steps in a moment. But first, I'd like to evaluate and see how well this model trained by AutoML does. So for this, I've written a short helper function, generate submission file that takes in a model and the testing data set. Outputs, well, creates a small data frame and outputs it as a CSV. And I'm going to run it. And fingers crossed, how many coffees was I supposed to drink? I think that's the question. 16 minutes ago. And my score, 0.66, cannot be that bad, can it? Let's see. Jump to my point, scrolled a little. 7.0. I can see this for sure, but looking at the remaining, so we have something like almost 18,000 participants. And I'm not in the first 16,000. We can say that for sure. So maybe I should have thought more and shouldn't have discarded all those columns. But I didn't do that well. Let's see how well I do with the AutoML generated file. Submit prediction once again. AutoML, just to make sure I'm not cheating. So this was just modified. It's 2 p.m. in Romania. Right, so open. Fingers, it's initializing the upload once more. Continues to initialize. 2. What if I submit them both? Will we get luckier this time? Behind one other. Oh, it's going to take a while. Okay. Let's look at how the train model looks like, and then we'll check our score. But basically, how does our model look like? Because I was really curious when I first saw this. I got really curious if I could tweak this. Because what I really enjoy about using automated ML in general, is that I can get up to speed with issues so fast. So let's say a customer comes to me and says, look, can we do something with this data set or that data set? And I can really easily just train a model, have it run for, I don't know, a day, 6 hours, and see generate a predictive model, deploy it in Azure or whatever, somewhere with Docker, and then write a quick app that that exposes that model to the customer, and then that he can try out really fast. And then we can tweak it and do analytics and do some data analysis and make sure everything runs well. Yeah, but I really enjoy that it gives me a quick baseline with which I can compare my my subsequent efforts. Yeah, so I started looking at how I can tweak it. Yeah, and first things first, we have if we look at the fitted model, if we look at all the properties of a fitted model, by the way, yeah, we see that, well, it has some methods that we could expect. Yeah, get params, set params, steps, transform both, predict, fit. Yeah, an interesting one is named steps. Yeah, because this gives us the steps of the pipeline and their names. So we can see that we have 3 steps here. First off, it's a data transformer. Yeah, this is added in only if we choose to do the automated featurization. Yeah, this is what this is the step that does the magic of pre-processing our data set and making it nice and ready to be consumed. A second step is this max ABS scaler that, as we've said before, it scales the data set to the same value space. And in our case, a LightGBM classifier that well, has quite some parameters. Yeah, let's look at them in depth and run them step by step, so we can understand how this pipeline looks like. Yeah, so I'm going to take the first step and store it in a transformer variable, data transformer, second step, and third step. But you see, the last time I ran this, I didn't have a max ABS scaler. Yeah, I had a standard scaler wrapper. So I wrote the notebook for that, but now it's changed. Automated ML. Yeah, sometimes these predictions might change. So I'm gonna use them. Ooh, I have the new Mac, the old new MacBook Pro. So if I type with double keys, you'll understand, I hope. All right, and let's look at the transformer, how this looks. Yeah, I wrote some small helpers here, but basically this is Microsoft specific. Yeah, it's in the AutoML runtime. Yeah, data transformer. Yeah, let's also run help on it. Yeah, but it's pretty well documented. Yeah, you can see what it tries to do. You can see how it handles things. If you want, you can even look at the code. It's quite nice. It's quite nice. But basically, this is what does the pre-processing, and that you can use in your own pipelines. So if you were to build a new pipeline with your own algorithms, you would be able to use this data transformer. How cool is this? Oh, I really love this. Yeah. Now, scalar model. This will most likely not work because I was using the standard scalar wrapper, and now I'm using the max ABS scalar directly. But we can see that, well, it's just this has just one parameter, and if we look at its type, it's from a scalar, yeah, standard open source component. Yeah. The classifier, well, the classifier, you'll notice that it has an embedded model. So basically, the classifier, we're using the LightGBM classifier class. But if you were to look for this online, you wouldn't really find it. This is Microsoft specific for, this is automated ML specific. Yeah, the actual LGBM class, it's LGBM classifier with almost the same arguments. Now, why did they do that? You may wonder. Well, we can look at the source code because we have the source code. Yeah, it's in model wrapper. So you can see that they added this class actually to be able to send in, well, let's say percentages of rows for as a hyperparameter. So let's say you in this case, you train a model with a data set. The data set has something like 15,000 rows, and they only wanted to use 80% of those rows to train the model for reasons unknown. This is the class that helps with this. Yeah, and you can look at the code You can test it, you can run it yourself. Quite nice. Okay, and I was in Firefox. All right, apart from this, getting back to the transformer, yeah, we can use it to see what features it has generated. Get engineered feature names. And we can see that it generated quite a bit. So how many? 7,000 out of a data set with 12 columns. It could be worse. It could have been 15,000. So, but why? Let's see why. We also get this insight. It's so lovely. So we have this get featureization summary that takes us column by column and explains what they did. Yeah, so for age, it's a numeric data type. We could get 2 features out of this. Yeah, one of them will be filled with a mean, and the other them, it's an imputation marker. Yeah, a marker that tells us whether or not this feature was null, because this might be important for the model. It's pretty cool. Yeah, with fair, it's not dropped, just mean imputer. We don't need to have a marker. Passenger ID, maybe not so useful, but because it's a synthetic feature, it doesn't help. But cabin, they decided to ignore the cabin, which is a good decision, right? The data from the cabin column, it's mostly trash, if you remember. Same with ticket. Yeah, it decides to drop these columns. With the embark port, it decides to do one-hot encoding. Yeah, and so on and so off. And with the name, it decides to use it. It decides to use it, so it splits the name. It does it uses word grams, and this gives us something like 7,000 features. And let's see how it works. Yeah, first off, so now we understand where that mountain of features comes from. Let's run the steps step by step to understand what's going on in there. Yeah. So first off, I'm going to use the testing data set and run the transformer on it. Yeah. See how it looks like. It's a sparse matrix. But using this code that I totally did not get from off the internet, we can transform this sparse matrix into a pandas data frame. We can look at it. Yeah. So we can see that we have columns for age with mean imputer, an imputation marker, fair, and well, all the columns from name later on. Yeah, it's pretty cool. This allows us to examine and understand what's going on and what the transformer does step by step. All right. And by the way, if we look at, we can double check this. If I load the original testing data set and look at the latest values, yeah, I can see that, for example, passenger ID 417, it's filled in with the mean value, yeah, and this is where it's nan, yeah. So the last values are 30.27. So we can check that it does the transformation correctly. What wonders me is why the imputation marker is 0 for each and every row, even though those clearly were filled in. I cannot say now for sure. Last time I ran this, it was okay. So the wonders of updating your SDK before having a talk, right? But now let's see what we can do next. We can transform this using the scalar. Yeah, we can transform this, and we can see that the values for age, for example, are in a different value space. That mean max absolute scaling. Yeah. So where the age was 34, 47, 62, right now is 0.43, 0.59, and so on and so on. Yeah, different. And then we can just run the results. It's pretty cool. Yeah, we get the array. We could inject our own algorithms, our own scaling, our own transformation at any step in this pipeline. So it's really composable. I cannot express how much I enjoy this. Now, fingers crossed. Oh my God, it worked. So 0.74. How well is this? I do not know. Not an improvement. It's an improvement. It's on position 15,000. So it's still better than before. And look, there are people who've done worse than us. So it can't be that bad. Now, but let's see if we can improve this. a bit. Yeah, first, well, at first I was afraid, I was petrified because the time is running out. But first thing that we could try is just let this run for more iteration. Yeah, if it jumped with 2,000 positions, just 3 iterations, imagine how many positions it could jump with 15. Yeah, but so that we don't wait, tapping our fingers on for something like 7 minutes until this runs. I've run this before. Yeah, run this before and store this as a fitted model 15. Fitted model 15. Let's take a quick look at it. It looks a bit different. Yeah, it has. It looks weirder. It has more text. Why? Well, because when we run this, when we give automated ML more iterations to run, it can also try building ensembles. It can also take the best performing models that it has found and basically combine them to create supermodels, yeah, such as this guy, voting ensemble, that can outperform the previous models. Yeah. So basically, what happens here is that we have something like, well, we have 13 lesser models, with air quotes. Yeah, and then automated ML picks the I think the best 5, the top 5, no, the top 1, 2, 3, 4, 5, 6, 7. It doesn't like to risk. The best seven models. If it gives each of them some voting power, yeah. So you can see that the second model has the most voting power. This is the weights, yeah. How much the vote of each model in the ensemble counts, yeah. And then it asks them all to do predictions, takes those predictions, multiplies them by weights, and uses them. Yeah, which is a cool idea, and you get that for free, but just by having it run more iterations. Yeah, you'll notice that now the model step is called prefitted self-voting classifier because I have it's a voting classifier. Yeah, these are the estimators. It's in the same file we were looking at earlier. It's in model wrappers. You can take a look at this if you want. And we can also examine the estimators. You see that it has pipeline number 3, that we've seen before. Yeah, it had pipeline number 7. Oh no, the pipelines with the best scores. Yeah, it combines them according to these weights. And let's see how well those did. Yeah. So I'm gonna try my luck with a quick evaluation. You see, it's just been generated. Yeah, AutoML. Is it uploaded? Fingers crossed. All right, make a submission. Man, it's my lucky day. And I got a pretty good score. Yeah, what did I do? I just let this run for 15 iterations. Yeah, and I'm on position 685. So if I were to just casually calculate how good I did, so let's assume it's 17,000. So I'm in kind of like top 4%. Without even trying. That's what I like about AutoML. Yeah, so I'm in top 4%. Got a really good score, but just by letting this run for more iterations. Can we do better? It depends on the day. Yeah, but I can show. I think I have. Let's say I have 3 minutes. I'm going to assume I have something like 3 minutes. Yes, awesome. All right. Thank you. Yeah, we can also activate the explainability for this thing. Yeah, by choosing model explainability is true. And what happens in that case? Well, in this case, hope everything is here. You can also see how important are the various features for the model. Yeah. I'm gonna re-download them, and you can see a feature importance dictionary that tells you, look, this feature is the most important. This feature is the maybe not as important. You might do well in optimizing this feature. But right now it appears it's hanging. No, it's not hanging. Waiting for me to say that, right? So we can see that the biggest, most important feature is if you're called a Mr. And so is this feature, who is in the top. So if you're called a Mr. with a dot, or a Mr. without a dot, or just a Mr. without a space, it means you don't have a good chance of survival, most likely. Yeah. So having a Mr., being a male, having a Mr. in your name, not great. Yeah, it's the same with the passenger class, the gender, women and children first. Yeah, how much you paid for your ticket, and so on. These are the features that we like, that are important. Maybe if you were also called Diane, I think it's a good chance, presumably. Yeah. So what we might want to do is basically just extract the titles from the names, have some new pre-processing, improve your pre-processing, maybe just tell it if, I don't know, have it learn a feature that says, I don't have any siblings and spouses, or no parents and children aboard. Dropping the passenger ID, which is useless. It cannot have predictive power. Yeah. Extracting the title from the name, and doing another run of auto into the mail. But I'm gonna leave that. I'm gonna leave you to try that for yourselves. And fingers crossed, you might, you too will do quite well in Titanic. Yeah, this notebook, well, a version of it is already online. I'm gonna update it after the talk. Put the link in the chat, and that's pretty much it, I think, so that we don't outrun this.
Oh, fantastic! Thanks so much, Vlad. That was really interesting to see that kind of progression from 170,000th to 685th. So no, that's amazing, and going into such detail on like all of the different settings that you can get in automated machine learning, but also then like you can actually just go and see this code. Like if you don't know what's coming out, go find out type of thing. Really, really great messaging. There was just one very quick clarification we wanted to do for an audience member. The original model you built with scikit-learn, was that a decision tree that you used there?
Yes, it was a decision tree. So
Cool.
I did use the worst model I could use, so logistic regression, but I also did not use the best model I could use. I just went with a reasonable default.
Yeah, no, I was like, was it decision tree? Yeah, so yeah, just to confirm to audience members, it was a decision tree. We weren't just guessing. And I guess the other thing that I just very quickly wanted to ask you was, you mentioned that when you run the automated machine learning model and you're running it on the same data set, even if the SDK updated, and you're sometimes seeing different answers, different results depending on the run. Any thoughts as to why that is? I think that might confuse people if it's like, oh, why didn't it just do it the same?
Well, basically, after all, it's a recommendation engine. So even though, so when we go to Amazon, it might show us some products the first time we visit, other products the second time we visit, but it's most certainly something we'd like to buy. So same with here, especially with a really low number of iterations. You might get either, in some cases, I've got the same results. In other cases, the results varied somewhat. But if and you can alleviate that by just having it run for a longer period of time. Yeah. And as I said, you can run this on your machine, or you can just configure this to run in Azure or whatever, wherever, and have it run overnight and come in the next morning and see the results, which is again pretty cool.
Yeah, very good, very good. And I love that you explained that you get to something decent really quickly, like, and that you said you use this with some of your own customers. Is that right? When you're kind of figuring out their data problems?
Absolutely. Well, I think it gives you a really good baseline. Plus, it gives you ideas on things you'd like to try. So, for example, with time series, We used that recently. You can just see it creating a lag for the time series or creating various features out of the datetime, extracting the year or the month or the quarter automatically. And that's just lovely. Maybe you wouldn't think to do all of that in the first case. So and I also like that it's really modular. So if I run it for a customer, create a predictive model, then I can take maybe the pre-processing and combine that with my own machine learning algorithm that I can tune later, or get the pipeline without the transformer and do my own transformations and then retrain this. It's I think a really well-designed piece of software.
Fantastic. Vlad, that we'll have to wrap it up there, unfortunately. Such a great session. Thank you so much for joining us. Please do share everything online so that all of our viewers and on-demand viewers can get access to all of this code. We will be returning, me and Iliescu, as hosts in about 10 minutes time. But first thing, just before we cut off, do check out the live.globalai.community website, because we're actually giving away some exclusive Azure Heroes learner badges. So Azure Heroes recognizes inclusive behavior and meaningful impact in technical communities. If you go to aka.ms/Azure-Heroes-badge, you can find out more there. I think we all learned a lot in this session, and we can all consider ourselves uber technical. So do go ahead and go and get those badges for all of your hard work for joining us. So thanks everyone, and we'll see you shortly.
Hey, my name's Akanksha Malik and I'm from Melbourne.
Excellent Somi, it's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉。
I'm Alpha Kassim from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi.
Hi. Hi.
Hi.
Hi.